Hello everyone, this is another tutorial video for Keep Talking and Nobody Explodes. This time we are looking at the module called Forest Cipher. Put that alarm clock there. So, Forest Cipher is somewhat notorious among the ciphers. I don't think it's actually as complicated as its reputation would suggest, but it does definitely have one sort of very tricky part that has earned it most of its notoriety. So, we will take a look through an example of the cipher here, and hopefully demystify that just a little bit. And so, like with most ciphers, we will start out just by writing down all of the stuff on the manual. So or on the module itself. QOFFT, the number 0, and the word data. There we go, come back on. And then on the second page, we get 3 keywords: replica, burrow, and soup. So, now having noted all of that down, we will swap over to the manual here. I'm also going to bring up my calculator because that's going to come in handy. And so for the first step in this cipher, we're going to need everything on page 1, as the manual says. So that's the encrypted word, QUOFFT, the number 0, and the word data. And so what we actually need out of these letters QUOFFT are the alphabetic positions there. So Q is the 17th letter, U is the 21st, O is the 15th, F is 6, and T is 20. And then at the start of that, we're going to put the number 0. So that 0 is not actually going to do anything this time around, but often it's 1 or 2, and then it actually makes a difference in your calculation. But so what we're supposed to do, according to the manual, is multiply your number by 26, and then add the next number in your list. And then just repeat this over and over again. Multiply by 26, add the next number. Multiply by 26, add the next number, and so on and so on. So effectively what we're doing is we're converting this into a base 26 number. So this is a 20 in the ones place, a 6 in the 26 place, another 6 in the 26 squared place, and so on. But we don't even have to worry about that. We can just sort of follow the instructions. So 0 times 26 does nothing. Then we add 17. Then we multiply by 26. Then we add 21. Then we multiply by 26, we add 15. Multiply by 26, add 6. Multiply by 26, add 6. And then one last time, multiply by 26 and add 20. So that will give us this whole large number, 211,847,760. So the next step in our process is convert this number to binary, which again we could do by hand with all sorts of dividing by 2 and keeping track of when we get a remainder and when we don't, or we could just use the programmer section of the Windows calculator here, and I can just type in 211,847,760, and then it will conveniently convert this to binary for me. So if we notice, this binary number only has 28 bits. We see these 7 groups of 4 here, so let me write these down. So there we are in binary. However, the next step says starting with a value n of 30, that means I need 30 bits. So I'll just tack on a couple of leading zeros here at the beginning, so I actually have 30 honest-to-goodness bits. And I'm going to break these up into groups of 5 for reasons that we'll see in just a second. Because now I'm going to use this third piece of the process, which is using the keyword data. So in this case, I'm going to use the numerical positions, again, of these letters, which D is 4, A is 1, T is 20, A is 1. And we're supposed to do this step 6 times, but you'll notice data only has 4 letters in it. Well, we just start repeating letters. So I loop back and I'll use the first D and A again as my 5th and 6th letters for this step. All right, and so now what this says to do is we cycle the least significant n bits, in this case 30 bits, to the right by m bits where M is this next number in our list. So we take these 4 bits right here, move them to the right, just loop them back to the beginning of the thing. And now we extract 5 bits off of the end of that string. So 00101, which we convert that back to a number, a decimal number rather, and that's 5, and that 5 represents an E, the 5th letter of the alphabet. And that was step 1. So now we just do that 5 more times, right? We have a 1 here, so that means we cycle 1 bit to the right, and then we take the last 5 bits, pull that off. So that, if we convert back from binary, is just 2. So that's a B. And sometimes when we're doing this, we get a nice shortcut, because we'll notice we're supposed to cycle 20 bits. Well, I only have exactly 20 bits down here now. So that means cycling 20 times does absolutely nothing, and I can just leave it all alone. So we get 00001, which is a 1, so an A. Then we cycle 1 bit all the way to the right. Oops. Oh, what did I just have there? Was that a 0 or a 1? Hold on 1 second. All right, I rechecked my arithmetic there, and it was in fact a 0 at the end of that. That's what I thought. So that means I'll take a 0 and cycle it all the way to the beginning. And if I have screwed that up, I'll just have to record this video again. No big deal. But so then that gives us 00101 at the end. That's another 5. That's an E. And then I now have to cycle 4 bits here. So 0011, we'll take that off. Cycle that back to the beginning. So now that's 10000, which is a 16, which of course is P. And then lastly, I'm supposed to cycle 1 more bit back to the beginning. That's a 0. So we get 00011, which is 3, which is a C. So what I've gotten out of all of that is a new 6-letter encrypted keyword, EBA-EPC. And so now all of this mess that I had back at the beginning, I can completely get rid of. All that comes forward is this EBA-EPC. And that's our first step of the cipher. Now we move on to the semaphore rotation cipher, which is only slightly ridiculous. But if you are familiar with any of the cycle modules, like Caesar cycle or any of those, you'll have the general idea of this one. So once again, I need to take my keyword from the top screen on page 2, which was replica. That's the 4th one in my list here. Convert all of those letters to their alphanumeric equivalents. So R is 18, E is 5, etc. And once again, since I only have 6 letters up here, I'm only going to need 6 keys down here, so I can get rid of that 7th letter there that's not actually necessary. And so what we're going to do is, the first thing I need to do is look at my encrypted letter, which is, my first encrypted letter is an E. And now, that matches up to this 18 right here, corresponding to the R. And so that means I'm supposed to rotate the semaphore representation of E counterclockwise by 45 degrees 18 times, because of that 18 right there. Well, of course, I can save myself some work, because going 45 degrees a total of 8 times brings you all the way around the circle to where you started. So every 8 rotations here, I don't actually need to do. I can just reduce mod 8. And so that really just means rotate it counterclockwise twice. So if this flag from northeast goes counterclockwise twice, that'll be northwest. And the south flag rotates counterclockwise twice over to east. So I want northwest east, which if I look in my process here is a Y. So this E converts into a Y after being rotated twice. And then we just do this for all 6 letters. So B is right here, that's west and south. We're going to rotate that counterclockwise 5 times, which is the same as clockwise 3 times. So this west, I think I said south and east, I meant south and west. West goes to northeast, and south rotates up to northwest. So that is a U in semaphore. YU. And sometimes we get a very nice shortcut here because this A, the third letter, is supposed to rotate 16 times, but 16 times will get us right back where we started. It will just be an A again. Then our fourth letter is an E, which goes with the 12. So E here, 12 times around the circle is really 4 times. Going 45 degrees 4 times, so that's going to be 180-degree rotation. So E, the south goes to north, northeast goes to southwest. So we want north, southwest, which is K. And then just to wrap this up, P, rotating counterclockwise once, we'll go to northwest, southwest. Let's see, we're not seeing that. Oh, there we go. That's I. And then C, going counterclockwise 3 times. 1, 2, 3. That'll be northeast and south, which is E. So now we have a new 6-letter encrypted keyword, which again will be complete nonsense, as the manual suggests here. And that's what we carry on to the next part. So now I can erase everything I had before. At least, assuming I got it all right, I can erase it. So let's hope that I did. But so now we have this 6-letter keyword that we have to decrypt somehow using a Rubik's Cube. And so this is where this module sort of gets its reputation as being weird and difficult, because there's this whole Rubik's Cube mess here. And so first let me explain very briefly what we're supposed to do. I'm supposed to take these I'm supposed to look at these last 2 keywords that we have here, burrow and soup. And then we do the usual sort of thing that we do with these ciphers, right? I take the letters in my keyword, get rid of any duplicates, and then I write the rest of the letters of the alphabet after it. I, J, K, L, M, N. O is already in burrow, so I skip that one. P, Q, R is already in there. S, T, U, V, W, X, Y, Z. So there's my whole alphabet, slightly rearranged to put burrow at the very front. And so now what I'm supposed to do is take this whole sort of Rubik's Cube shaped thing, right? So I've sort of drawn this to look 3-dimensional. So here's the top layer, here's the middle layer, here's the bottom layer. Oh, I'm not supposed to have, whoops, don't do that. I'm not supposed to have this space in the middle. That's just supposed to be empty. Because you could never see that on the outside of a Rubik's Cube. And I'm supposed to put these letters in there. So I put the B here, and the U here, and the R here, and then let me get this in the right order. Whoops, nope, sorry, I'm supposed to put the R over here. And then the O goes here, the W goes here, and then the A goes down here. So already this is weird, because I'm looking at the middle of each side, and those are the letters that go on first. So B is the middle of the top side, U would be the middle of the front face, if you're looking at the things closest to yourself in the 3D picture. Then the R is the right, O is the back, W is the left, and A is the middle of the bottom face. And then I write in the rest of the alphabet, A, C, D, E, just sort of left to right along the front face, F, G, H, I, J, then across the middle face, so the middle row of each of these, K, L, W and R are already there, so we just skip those, M, N, P, Q, S, T, V, that one's an actual X now, and then Y and Z. All right, so already it's a pain just to put those on there in a way that we can sort of visualize what's going on with this Rubik's Cube. And I realize I got that down a little bit out of the shot there, but so this is what this would look like after our cube is set up. And now I'm supposed to spin some things around on this Rubik's Cube. So we look at our second keyword, which is this soup right here. And now each one of those letters is supposed to give me a rotation of the cube. So the letter first tells me which face I'm supposed to move. So the S says I'm supposed to move this left-hand face. And then this table down here tells me how many times I'm supposed to move that. Right, so this says I'm supposed to move the left face in this rotation exactly 5 times. So that would be the P, the K, the C, the T, the W, the F, the X, the M, the H. And then we rotate this 5 whole times. The W doesn't move because it's in the dead center. But so like the C would move forward 5 spaces. 1, 2, 3, 4, 5. So the C moves to where the T is. And so this is already difficult because if I, delete the T to say, oh, there's supposed to be a C now, I've got to remember that that T is there, right? So maybe I'll just write down my letters, C, F, H, M, X, T, P, K, and then we'll just rewrite those. So C rotates all the way to here, the F rotates all the way to here, the H goes here, the M goes here, the X goes there, T, P, K. And that's just one of the rotations, right? Now I'm supposed to do this again for the O in soup, which rotates the back, because that's where the O is, 5 times. And then the U rotates the bottom face 1 time, because that's where the U is in the table. And then the P rotates the back again 7 more times. All of this is a horrendous mess, and frankly, I never do it when solving this module. I'm just going to get rid of it altogether. Here's what I actually do. So I take my alphabet key, I write this out the way the instructions told me to, and then I line this up with this alphabet key over here. Because what's supposed to happen, by the way, eventually is after I write down all those Rubik's Cube rotations and whatever, then I look for like, okay, where is the Y in the cube that I made, and then what letter is in the same position in this cube in the original manual, right? This cube A down here. So I look at the Y, look at where it spins around to, and then compare which letter it lines up with in this cube over here. All right. So rather than actually writing out the whole cube, though, I'm just going to focus on what are the letters that I actually care about, right? All I care about are the letters Y, U, A, K, I, and E, and where they go on the Rubik's Cube, right? The other 20 letters don't bother me at all. So here's what I'm going to do. I'm going to look for this Y in my alphabet key and see, okay, this corresponds to a Y right here. So that actually would be the Y on this actual cube, the starting cube. So that's in this spot right here. It's a little bit small, but unfortunately those pictures won't zoom in this viewer. So we just have to keep track of the fact that the Y is right there. And now let me look at the rotations that are supposed to happen. Well, this Y is in the middle of this cube, right? It's the middle column of the cube, which means that S rotation that moves to the left, that doesn't do anything. That does not affect the Y at all, right? The Y is not included in the stuff that gets rotated by this. So I can just skip that. Now, when we get to the O, right, the Y is going to move. It's going to move 5 times around in this direction. So 1, 2, 3, 4, 5. So now it's on the R, right? The Y would move to the position that the R is in. Now, the down, the U rotation rotates the bottom face of the cube. That does nothing. And then the last step, the P, moves the back face again, which my R that I'm now keeping an eye on really will move under this. It'll move 1, 2, 3, 4, 5, 6, 7 spaces, and it winds up on the S. So all of that says, if you actually put the Y onto that weird Rubik's Cube that I had before, did all those rotations, it would wind up in this precise spot. This spot right here where the S goes. And for our decryption purposes, that means the Y turns into an S in the decrypted word. So all I have to do is do that 6 times. I don't ever have to look at the entire Rubik's Cube. I just do each letter on its own. All right, so let's see that again with the U. So the U in this spot on the cube would actually go here where the E is, which I can see based on how my alphabets line up with each other. Right, the U matches up to the E, so that's this spot right here. And now I have fantastic news, right? This E would only rotate if we ever rotate the front of the cube. But if we rotate the left or the back or the bottom or the back again, that E does not move in the slightest. So that U on my original cube, I would have had to write it down, do a whole bunch of complicated calculations and stuff to see that it doesn't actually move. It just stays right here in the front middle part of the cube. And so it turns into an E at the end. Right? So sometimes you have to do a lot of spinning around of the cube. Sometimes this just tells you, oh, that letter doesn't move anywhere. It just turns from this U into this E, and then you're done, and we move on to the next one, right? So you can just save a lot of time this way. So let's see, next up, the A turns into a P. Well, this is also fantastic news. The P is in the bottom middle of the cube. And if you have ever played around with a Rubik's Cube, you know those middle faces just don't move, right? Even when say, the bottom part of the cube rotates, this P just sort of spins in place, right? So that P is going to stay exactly where it is. That turns into a P. K turns into a J. According to our alphabet keys, that is on the top left here. And so now this is going to move, right? When the left face of the cube rotates, the J is going to move. S says we rotate that 5 spaces, so J moves 1, 2, 3, 4, 5. Now O says, okay, the back is supposed to move 5 spaces, so this X, which is on the back, moves 1, 2, 3, 4, 5 to another S. And then let's see, U moves the bottom part. That doesn't change the S at all. But then the P moves the back part again. That moves 1, 2, 3, 4, 5, 6, 7 spaces back around to the T. So the K turns into a T. And at this point, frankly, I feel like the word is almost certainly going to have to be septic, but let's just finish out the last 2 letters to see. So I turns into H. So let's see. H is at the very front bottom middle part of the cube right there. So the left movement doesn't affect that. The back movement doesn't affect that H. The down does. So this U says, okay, rotate the bottom part of the cube, but only move it once. So H moves over 1 spot to the I, and there we go. And then lastly, E turns into C. If we look at C, once again, we're in the happy spot where the left movements, the back movements, the down movements don't affect this C. It's not going to move at all. It just stays where it is and becomes a C at the end of all the things. All right. So you could have actually done all this by writing down the entire cube, doing all the rotations of every single side, but for several of our letters, the P, the C, the E, they didn't move at all. The only thing we had to look at was what did they correspond to in the second alphabet key, and did that spot actually move in the final cube? And it didn't move at all, right? These rotations defined by SOUP didn't actually move the cube, move those particular letters at all, so we didn't have to do any decrypting of those. So hopefully that will save you some time and also demystify some of this Rubik's Cube stuff. It does take a little bit of practice to kind of visualize how the spinning goes around in these Rubik's Cubes over here, but I think it just saves you a ton of time in the end because you don't have to track, the other 20 irrelevant letters and how much they move in your Rubik's Cube. You only have to look at the 6 that you're actually trying to decode. And of course, you save yourself even more time if there are any repeated letters up here, because then that's just less stuff that you have to check. All right, so now that we have our final word septic, we can go back into the game here. And, whoops, click the wrong button. I was just trying to get focus back on the module there, but I screwed it up. So I clicked submit before it actually typed anything, and somehow nothing wasn't the right answer. But if I just type in the word septic here, and click submit, there's our answer. So hopefully this helps you understand this module a little bit better, and happy solving.